Hi, my name is Jeremiah Ets-Hokin, and today I'm going to be talking about a potential safe harbor for coral and algae. Since 2014, we have seen dramatic ecosystem shifts in California kelp forests. Kelp abundance is decreasing due to warming and increased urchin grazing. Urchin predator populations like sea stars are decreasing due to sea star wasting disease. Urchin populations are increasing and are grazing down once healthy kelp forests to the point that only urchins and coral and algae are left, a state known as urchin barrens. Within these barrens, urchins are now grazing on coral and algae at unprecedented rates. Urchins are grazing coral and algae to the point that reefs are experiencing significant habitat loss, and under ocean acidification conditions, it has been shown that coral and algae has a weakened skeleton density and is more susceptible to this urchin grazing. So why do we care about coral and algae? Well, these slow-growing organisms are early colonizers of disrupted ecosystems worldwide. They're foundational species, and they induce larvae settlement of many commercially important organisms, like the red abalone is shown here. Luckily, there's some hope for coral and algae. Coral and algae is unique in that it's both a photosynthesizer and a calcium carbonate forming organism. This allows them to create a biologically significant diffusion boundary layer that can protect them from ocean acidification conditions. What I want you to understand from this image is that under slow flow environments, this diffusion boundary layer gets thicker and more protective of the coral and algae. And under fast flowing environments, it gets thinner and less protective. So with that in mind, it brings us to our central question, which is, can diffusion boundary layers give coral and algae safe harbor from urchin herbivory when faced with ocean acidification conditions? So to answer this question, I've designed a novel aquarium study where first coral and algae will be collected from rocky reefs in Monterey, California, and placed in one of 4 treatments. The 4 treatments will consist of more acidic seawater, which will reflect ocean acidification conditions in the future, less acidic water, which will reflect past conditions that our oceans were in, thin, and that'll be crossed with thin diffusion boundary layers, which will create a less protective layer, and a thick diffusion boundary layer, which will create a more protective layer. And then we will let the coral and algae grow in those conditions for 1 month, at which point we'll place urchins and let those urchins graze on the coral and algae for 20 days. After those 20 days, we will be able to answer our central question. So if this protective diffusion boundary layer is creating a significant safe harbor from ocean acidification, we would expect to see more urchin herbivory in coral and algae that grew in treatments with less protective diffusion boundary layers. Knowing how these species interact would allow us to better predict what these ecosystems will look like in the future and how to better manage them. Thank you very much.